Now that you have a better idea of Kafka internals at a high level, let's hit the ground running and check out some performance tuning. In this exercise, we'll be producing events to a Kafka topic in a Confluent Cloud cluster, tweaking some client settings, and then observing the impact they have on event throughput and latency. But before we get into that, there are a couple prerequisites that you'll have to go through just to make sure your environment is properly set up. The instructions on how to do so are included in the write-up just below the video, so take a look at those before we continue on with the exercise. When you're finished with that, we can dive in. If you've completed the exercise setup, you should have created a configuration file using the Confluent Cloud Console Java Client Configuration section. This configuration file includes the cluster endpoint that will be used by our performance test script to establish a connection with the cluster. The config file also contains authentication settings, so it's pretty important to have it set up properly. Let's check out the config file and make sure all of the right details are in it. Like I said, you should see the cluster endpoint as well as your authentication settings. If your config file doesn't quite look like this, revisit the setup instructions before continuing. If everything looks good, we can now begin testing the producer client performance. To start off, we'll just use the default producer configuration values. Two of the most important producer settings related to event throughput and latency are linger milliseconds and batch size. The linger setting is the maximum amount of time that the producer will wait while adding events to a record batch before it's flushed. The batch size setting, of course, is the maximum size that a batch can be before it's flushed. The defaults for these settings are 0 and about 16 kilobytes respectively. In the next few tests, we'll alter the values for these settings and observe how they impact the average throughput and latency. A quick thing to note before we start running our tests is that we'll be throttling the record output of the script to make it easier to observe throughput and latency variations. With that, let's kick off a test with the default settings. You'll notice a couple key options in the performance test command. We'll set the record size to 1,000 bytes and specify that the test run through 3,000 records with a throughput of 200. But of course, the most important property is producer props, where we set linger and batch size. We'll use the print metrics flag to output metrics, limiting the output using grep. The output you see could be a bit different than shown here, but you should see something similar. In this case, the average batch size was 1,215, much lower than the default batch size. This is easily explained by the linger value, which was set to 0. Since linger was so low, the batch is being flushed almost as soon as the first record is added. Doing a bit of math here, since our record size equals 1,000, it appears that one record is being added to each batch before linger triggers the flush. Let's quickly review the remaining output values. The buffer pool wait ratio 0 value indicates that batches are never waiting on previously sent requests in order to be flushed, meaning that Confluent Cloud brokers are able to process requests as fast as we're sending them. Pretty cool. Outgoing byte rate and request latency average shows the throughput and latency results. And finally, we have a record queue time, showing how long that records are remaining in the batch prior to being flushed. Now that we have a good understanding of the output metrics, let's run the same test, but this time we'll increase linger from 0 to 100 milliseconds, giving records more time to be added to a batch before it's flushed. Let's analyze these results. With linger set to 100 milliseconds, you'll first notice that the average batch size is much higher. It's actually just lower than the batch size we specified in the properties. This indicates that the batch size is what's triggering the batch to be flushed now. Notice also that throughput has decreased and latency has increased compared to the previous test. That's actually not what we want. Let's rerun the test, increasing batch size to 300,000. Looking at the output results, we see that the average batch size has increased, but not by that much. This indicates that the linger setting isn't allowing enough time for batches to reach the limit set by the batch size parameter. Throughput and latency are still moving in the wrong direction. The next obvious thing to do is to increase the linger time. Let's see how this affects the output. With linger set to 1500 milliseconds, we can see that the batch sizes are pretty close to the batch size limit, but we're still losing ground in throughput and latency. It appears that the producer defaults for linger and batch size are actually the best choice for an application that's producing 200 records per second of 1000 bytes each. In this exercise, we got a pretty good feel for producer settings and saw how altering these configurations can have an effect on throughput and latency. But keep in mind that we only checked these settings for a specific application based on the number of records and record size. So I do encourage you to continue playing around with the performance tuning script and change the input parameters to reflect an application that you're currently working on. In order to do that, you might remove the throttling on the performance test by setting the throughput equal to -1, and then altering the num records and record size values. Observe the results and let me know what you find. That said, when you're finished running this exercise on your own, you'll need to tear down the exercise environment, deleting the Confluent Cloud cluster and preventing it from unnecessarily accruing costs and exhausting your promotional credits. Let's walk through the teardown process together by using the Confluent CLI. From a terminal window, log into the CLI. I recommend using the save flag so that your credentials are saved for use in later commands. List the environments available to you. With the environment ID, now you can list the available clusters. We used the performance test cluster in this exercise, so we'll use that ID along with the environment ID to run the delete cluster command. And of course, as a sanity check, we'll list the environment clusters again to confirm that the performance test cluster no longer exists. The cluster is not listed, so the environment teardown is complete. And with that, we've successfully wrapped up our first Kafka internals exercise. You should now have a pretty good idea of how producer configuration settings can impact your application and how to fine-tune these settings to optimize throughput and latency. I hope you found this interesting and that you'll join me in the following exercises as we continue to dive deeper into Kafka internals. See you there!